All right, afternoon everyone, happy Saturday. I wanted to present the Roamy robot, which I have one right here, turned on, and just go through what it is and how it can be useful for your team learning programming. A little bit about me first. I work for Team 7272, High School for Environmental Studies here in New York City. I've been with them for many years, and the actual seasons is kind of weird because of COVID, as you know. But our rookie year is 2018, and I joined them as a professional mentor to help out. And a lot of what I do is handling all the purchasing for the team and expense reports and budgeting, also organizing preseason boot camps, learning activities for new students, and kind of just help the team with everything, like what this mechanical component does, how to wire the robot. As an adult, we're still a very new team, so a lot of times we have a brand new set of students come in, especially after COVID, and need to know everything, so I'm kind of doing everything, including programming. Personally participated a long time ago in FRC, back when the control systems, mechanical components, vendors were completely different from what they are today. It's a lot more modern, to be honest, than it used to be. And I was on Team 2139, which doesn't even exist anymore because the high school reorganized. I've been focusing a lot on helping build resources for not just my team, but lots of teams. Later, I will demo the online course for learning programming and using the Romy, which I contributed to over the last 6 months. And what I really do in my day job is I'm a software engineer for MongoDB, which is here in the city as well. So, who knows what the Romy is? Everyone knows, kind of, heard about it, not heard about it? Okay. Who has one or is purchasing one but doesn't know what to do with it? Or, okay. And who's like an expert, done tons of programming with it, lots of different activities, even like done vision or practiced PID. Yeah, okay. All right. So I'm starting all the way from scratch in this presentation, assuming that you know nothing about it, and hopefully you'll learn some things you didn't know about it as part of this presentation, and then we'll get into more advanced stuff. What I would like to do at the end, live demos never really work, is actually like code a command, run it on the Romy, and see if it actually works. So the Romy, some people pronounce it Romy. I don't really care. It's not about how you say it, it's about how you use it and understand it. But it was developed so that you can learn programming directly applied to FRC robotics coding in a much smaller environment. And this little tiny robot, miniature scale, it allows you to write WPILib style code, robot projects, things like that. Runs on AAA batteries. Some technical details is that it is different than a regular Romy robot, like the first Romy robot together. It needs a Raspberry Pi on the top with the physical control board underneath, and they communicate with each other. And that allows a actual Linux operating system to be able to run Java or C++ on the Romy itself, which the two chips together simulates the equivalent of a Robo Rio, which is what you have on your actual robot, being able to run the whole OS. And technically what happens with the Romy is the robot project program actually runs on your laptop, and the actions and input and output is streamed between your laptop and the robot itself. So it communicates via WebSocket between WPILib Pi, which is an image on the Raspberry Pi, and the computer. So technically, it's running on your computer. But you can use the Raspberry Pi for a lot of other things as well. and it all happens over Wi-Fi. So why is the Romy so great? It's like this different thing that FRC teams have to buy and use and maintain and set up and all of that. So the biggest thing and most powerful thing that I've seen is that it's take home and that you can learn at home. And you're using the time, the very precious hours you have in your robotics labs, building the robot, doing physical things. It allows you to learn at home and then apply later at the school. And it's, as a programmer, it's very hard to get access to the actual robot, to upload your code, to test the driving while it's being built and while you're in the middle of the season. So this provides a place for brand new programmers, never programmed in any languages or programmed FRC style code. You get to learn all of the things about it in an isolated environment. Trying to learn programming in a workshop next to the robot while it's being built is very loud, very distracting, very kind of frustrating, right? And this can be done separate in a different classroom, or with your school's permission, take it home with a laptop and do the online exercises and learn on your own time. And for my own team, even as a software engineer, I have also struggled to, have access to the robot, even with keys and all of that, to the robotics room. It's very difficult to test your actual code, learn things like PID, without taking something home and just having extra hours. And it allows multiple students to program. So you're increasing the amount of programmers on your team by being able to purchase many Romies, give them out to different students or groups and have them share them for a lot less cost. And the lower cost presentation is in a second. And it's a little bit safer. I don't know if has anyone ever programmed a robot, thought that their code was going to work, and then it just drives straight and crashes into a wall on the other side of the room, right? And you can troubleshoot code a lot easier with the Romy and have less catastrophic consequences as a result. And whenever I program something, I'm not sure what the Romy's going to do. I kind of just hold it so that its wheels can turn. Can't really. I guess you could prop all of the wheels of your drivetrain of your real robot off the ground to make sure that it does what you think it does, but it's easier with the Romy just to get started in learning. So the cost is so much smaller than our really expensive FRC control systems. So I think what teams have done before the Romy was invented and realized is buy multiple real total control systems. You'd have one on your last year's robot and the one before that, and then purchase a whole new system for this year's robot so that there's multiple robots being able to be used at once. But it's very expensive. It adds up really quickly to get a Robo-Rio, a power distribution panel, radio, battery, the motor controllers, and a chassis, and kind of the bare minimum supplies is really expensive to have everything wired and connected together. The Romy base kit, no upgrades, no extensions, it's $200 each, which is a lot more reasonable. It's half the price of just the Robo-Rio, to be honest. It's kind of amazing that something so small and simple can run the same code, very similar environment for a lot less cost. And I guess you could argue, well, you could take out this component or that component, or you don't really need a chassis. What sensors are you using? What's the cost difference there? But no matter what you do, it's always going to be a lot cheaper. So one thing that you have to think about in your budget is, even though it's only $200, like, can we afford it? We have a lot of supplies that we need to do, and it feels kind of weird to put money into an alternative system like the Romy when you can't use anything on your robot, right? So it's like the separate thing, but I think that the learning, now that this system exists, the learning is going to impact a lot of the quality of our code at the competition. I'm hoping that I see a lot more teams uh, at regionals not just have like a robot sitting there during the autonomous mode, right? Because you're able to, in the chaos of the season, uh, programming is often very left to the last minute, can't really be parallelized. It's difficult to test and learn sensors and physics and all of that stuff. So I think it's worth it. I would definitely try to find time in your budget, and technically the Raspberry Pi and other related components could be used for your vision system. So that's a way that you could just rationalize it a little bit. Say, hey, if I program a vision system on the Romy, I could actually disassemble it, put it on my robot with the Raspberry Pi camera and green LED, green light tracking, or whatever you decide to use. And I think that's a rationale to make it feel a little bit less expensive. And we all know that budgets are tight across everything. So what can you learn on this Romy? You can learn programming basics, how to use methods, variables, objects, general program structure like classes. You can learn how to troubleshoot and debug code, like why did my Romy just drive straight and I wanted it to rotate instead. You learn FRC programming basics, so you learn what a time-based robot project is. You learn command-based programming. You learn the general structure of what a robot project is and WPILib. And you learn the modes and sequence of a match: autonomous mode, teleoperated, disabled mode, how to initialize things, how to do things in different parts of a match. And then you get to learn WPILib specifics, digital inputs and outputs, interacting with motor controllers. The thing that I think is really cool is that all of the same classes work on the Romy, and they're kind of, you don't get to use the like exact motor controller classes. Like I have Spark Maxes or Victors or Talons or whatever on my robot, but that's just a subsystem change in your code. Like you swap out which classes get applied to which motor controllers. That's kind of like a detail that you leave for your actual competition program. I've also played around with PID on here. It was the first opportunity that I was able to actually do it, because it took a while for me to like learn it at home and play around with it and tune PID and realize what it actually does, which in a lot of the examples, PID is just a fancy way to correct the direction. So later I'm going to demo turning the Romy 90 degrees based on the gyro. And about half the time it's going to go a little bit past 90 degrees and it doesn't turn back. And that's what PID does. It's like, oh, I overshot 90 degrees, let me go back a little bit and keep adjusting and making sure I'm exactly at 90 degrees. And I had never even been able to try out PID on my own because there's just too much happening in the workshop and we're trying to focus on building the robot. I thought it was really cool to finally be able to do it. And you can actually use the same input devices, game controllers, joysticks, keyboard, buttons. You could wire up arcade buttons, whatever you want to do. You can use the same devices to drive the Roamy around. You can also learn about sensors and more autonomous programming. There are both encoders on each wheel side, and there's an onboard gyro and technically an accelerometer. I haven't personally played with the accelerometer because I kind of like the gyro. And you can actually do a lot of fancy path traversal algorithms with it, instead of just the basic turn 90 degrees based on the gyro or encoder goes forward a certain number of inches. You can go really advanced. And there's abilities to solder or connect additional sensors on here as well. Both, there's two things you can do. You can put sensors directly on the digital I/O pins, which is very similar to the I/O pins on the RoboRio, or you can add sensors and vision equipment or whatever to the Raspberry Pi, and you can write a program that communicates the signal data between the WPILib program and the Raspberry Pi operating system through network tables. And network tables is just like a fancy way to share data via the Wi-Fi network between the Raspberry Pi and your computer. And it's very similar to what you would do on a RoboRio and on your robot network. Technically, there's like a little local network happening on your radio that you can communicate with Raspberry Pi and RoboRio as well. I tried Robot Vision too. I didn't write my own custom program. I used a program that I found on Chief Delphi that someone built specifically for the Romy, and connected a Raspberry Pi camera and had like a green LED ring connected as well, and I was able to, with PID, track like a white piece of paper, which is very similar to every year the competition changes a little bit, but sometimes there's like a strip of reflective tape somewhere, right, that you can track. And you can you can purchase the same tape, stick it in the same orientation on your wall at home, and actually like play around with the real vision system, and then take the vision system off of the Romy and put it on your real robot. And I think that just being able to do that at home is going to be amazing for a lot of teams. I also thought it was really cool that you can use some of the FRC tools, including the smart dashboard and the shuffleboard. So anywhere in your program, you can output what's happening with your robot, and you just like put like, here's the angle that the gyro is at, or the speed that the motor is going at, or wherever. You just write a line of code and it can show up in a program where you can actually visualize what's happening on your robot. And you can also extend your base kit. There's a Roamy Arm, which is on the right, that is provided by the vendor, and it allows you to pick up objects. It has a sensor on it that tells you whether something's picked up or not, and there's 2 axes, I believe, and 2 motors that allow you to move it in different ways, or you can attach any sort of sensors that you want, like on the left side, to do vision or IR. I think those are actually LiDAR sensors, maybe. So there are limitations though. What you can't learn is really subsystems. A lot of the Romy projects come with a subsystem class already configured, and the actual subsystem programming is really basic, because the base kit is just a robot with 2 wheels, an encoder, 2 encoders, and 1 IMU, or gyro and accelerometer, right? If you buy extra things and expand your Romy out, then you get to practice a little bit of subsystems. But to be honest, the main subsystem programming that you're going to do, which is writing classes that actually communicate with the physical hardware on your robot, is going to happen on your competition robot. Mentioned this a little bit earlier, is that the exact classes and components that you're going to program with on your robot is going to be a little bit different. The sensors are going to have different tolerances. The gyro model on your robot is going to be a little bit different than the gyro on the Romy. Your switches and other things are going to be a little bit different. And the physics is going to be a little bit different. The like 100% power on the Romy is like not that intense, but 100% power on your FRC robot is really high because the voltages are a lot higher, and you're going to have different friction situations and just like different things happening where the code on the Romy will act a little bit different than the code on your robot. And the most awesome thing about FRC is the scale and the complexity of the mechanics and the life-sizeness of the program, right, in the arena and competition. And the basic fundamental programming knowledge of the Romy is really good, but everybody's going to be a lot more excited and interested in building the real robots, right? So eventually you learn a little bit here, but eventually everybody's going to transition into wanting to program and build the real robot. But it's very good pre-season activity, learning and programming the Romy. You can't use all of the FRC software, so I'll demo in a bit, but you wouldn't use the actual FRC driver station program with the Romy. You're going to use the simulation tool. So the exact software you're using and how it works and all of that, you'll have to wait for your actual competition robot. And sometimes how the software works gets realized at the regional competition when the field sends you like specific data that you've never interacted with before. Like the 2020 competition had this color wheel, and the field would actually tell you like which color to turn the wheel on, right? Those kinds of things would probably only happen at the competition, and you can try to like predict it ahead of time, but what if you actually accidentally code it to lowercase blue instead of uppercase blue? You realize that you have a bug in your code, and you don't realize that until a practice match, right? So there's an online course for learning the Romy, and it was advertised in the FRC blog and the lead mentor email blasts, and I have actually been helping develop it, and I'm actually in recordings and helped build a lot of the content and suggest to FIRST as a programmer on my team what's missing and what needs to be learned and all of that. So there's a portal I will show in a little bit, and it's a combination of videos and quizzes and direct links to WPILib documentation, and every lesson in the course starts out with assuming that students have no knowledge in programming. So first you have to learn what is Java. It is a Java-based course, not a C++ course, by the way, and we chose Java because it's more widely used than the C++ version. And you start out by learning Java concepts, and then you directly apply it to robotics programming and using the Romy. So you learn what the program structure is, and then you run an example project. You learn what objects and methods are, and then you call a digital output class that turns on and off the lights on the Romy. And it builds up from fundamentals to more complicated things like different variables, how to write equations and if statements. Command-based programming is also in there, how to use input devices, command groups, and both in what to do when you have exceptions or code isn't working correctly, troubleshooting, and how to use the FRC Smart Dashboard, Shuffleboard programs. So copied on this link if you don't have access to this, but I will also show and demo how your lead mentors can give you access to it. So the course is hosted in a system called Thinkscape, and teams have like this access code link to it. So what you have to do is have your lead mentor. Is everybody copied down the link that wanted to? Okay, cool. So what you have to do is go into the lead mentor 1 or 2 has logins to do all of the financial and legal stuff for each team, right? You have to make your payments in here and register your team, pick your regional, do like kickoff kit, opt-ins, opt-outs, and manage all the youth members and have them sign off their legal paperwork and all that stuff. But there's this button here called Access Thinkscape, and it shows up for all teams throughout the whole year, no matter if you're paid or not, because a lot of FIRST knows that a lot of this content will be used in preseason before you've paid at the beginning of each school year, and that leads you to a link here. There's 2 modules, like a basics module and then an advanced module right now. But to provide the link to your teams, you have to click on this admin portal link right here, click on the course, and get this invitation code. And this is like my team's code, so I don't have to copy this down. But basically, if you provide this link to all of your students on your Google Classroom or whatever you use, to communicate with your teams, Slack or Discord or Teams, whatever. Share this out with your students, and they'll be able to get into this course. So what is the course? It's as I said, I hope this loads. Okay. It's a mix of text content and videos. And there's introductions to how things work, and which kind of gives an overview of the Romy and what you're going to be doing. And there's kind of a learning theme in here, pretend you're a software engineer for a robotics company building programming this new robot. And there's assembly instructions. What I decided to do for my team is just assemble all of them for them, determine the Wi-Fi names that I wanted each one to have. So I do FRC Romy 1, 2, 3, 4, 5, 6 kind of thing. And the students would just skip to the programming robots exercise where they learn what is a robot project, how is it structured, what do all the methods mean, and so interactiveness a little bit of WPILib documentation, videos with recordings, and multiple choice questions at the end, which mode is designed for teams to try out their robot outside of a competitive match. And that is the test mode. Submit. I got it right. So there's 2 sections: getting started programming robots, using objects and methods, conditionals, variables and equations. And then the second course was released last week, and it has more advanced topics, including command-based programming, learning all of the different methods in a command, what they're used for, how it works, a little bit of like background and like how like the command scheduler works and some advanced topics about it. Robot driving and inputs, more advanced conditional statements, grouping commands together, using arrays and loops as well, and errors and troubleshooting and using the smart dashboard. So that's it. I personally put a lot of time into it. The recordings were a lot of work, and just like talking with FIRST and a lot of other mentors across the country about like what should actually be in this course and designing it. So I hope everybody learns a lot from it, learns some new things as well. So this whole thing was actually developed with coordination of mentors that are very close to home, actually. ZQ and Joe at Bloomberg, who are also mentors and team leads for 2 New York City located teams, and it was a coordination between them and the WPILib team to make this happen. And they had a lot of very creative ways to expand what used to be just a vision library. That WPILib used to be just a place where you can create like a low-cost vision system, connect it to your competition robot, and use that for vision. And what they did is they expanded WPILib to also work with this Romy robot and be able to control the whole thing. So definitely thanks, and if you see them by the regional or at other New York City events, definitely reach out and say thanks for all their hard work during COVID to make this happen. I did that already, so what I'm going to try to do, and I was also trying to do this morning, and I was having a little bit of network issues with my Romy, but I got it to work before this presentation started, is try to show how you program the Romy from start to end. So I'm going to create a new robot project using the Romy template, create a new command that uses the gyro, turns the robot 90 degrees, then stops. And I'm going to try to configure the command to run when I press the Z key on the keyboard on my computer. And then I'm going to connect to the Wi-Fi network and run and test the program. So let's see how that works. I think I'm good on time too, until 2:10. And maybe we'll end early and have questions. But actually, I want to do questions first, because I'm not sure how long this will take. Does anyone have specific questions or thoughts? Yeah.
I do.
Yeah.
Could you let me know what, just from a kid's laptop, in order to participate in this, what if a kid just takes a laptop off the shelf in the lab, not having any FRC stuff on it, could you let me know what needs to go on that laptop for them to do this?
So the most annoying thing is that it needs to be a Windows or a Mac, not a Chromebook. And that's always a frustration with all of us with FRC, is that it doesn't work on Chromebooks. So that's the first thing. So we did get a Windows laptop cart for our team from the school. The basic thing that you need to install is the WPILib installer. So if I go to this is really what you need to follow. You don't need to install LabVIEW. You don't need to install like the NI software, like the National Instruments software that comes with the driver station and all of that stuff. It's just VS Code and WPILib together. But WPILib installer like helps you install VS Code as part of its installation process. So you just download from GitHub the latest WPILib, and there's like a releases thing down here. So you pick the operating system that you have, you install that, you can, and when you run it, it prompts you to install VS Code. And what I like to do is like have WPILib download the VS Code once, and then I put that on a flash drive, and after downloading it the first time, it's a lot easier to like install it on all these other laptops. So I always handle the software install for the kids myself before the meetings or before the season starts, and you always kind of have to upgrade from like 2020 to 2021, 2022, and I prefer to do that just because I want to save the hours that we have together with like actual learning and doing things, right? So that's what I recommend following. Does that help?
Yes, thank you.
Okay. Any other questions? Okay. Let's see how this goes. Let's switch laptops. Cool. So I already have a program running with what I'm about to code with the robot simulator open. So this is where I can switch between, I think it's still connected. I can tell it's kind of connected because I'm moving the gyro all sorts of different directions, and you can see the little decimal output working. So sometimes I do have connection issues, especially at my house where there's just like a ton of Wi-Fi networks in the area. And that's caused me some pain, but I can click on the autonomous mode, and it's gonna run the autonomous mode, which really just, let me see if I can do it here. I don't know if you guys can actually see that, but it basically runs a command group that goes straight, turns 180 around, goes the other direction, and turns back to its original position. So let's try to do some programming really fast. So this is my example that if I get lost, I'm going to reference here because all the code's working and everything. So what I'm going to do is create a brand new project. When you have all the software installed, you just click on this WPILib command palette button, and it brings up all of the stuff that's related to WPILib FRC programming. I'm gonna say create a new robot project. I'm gonna click on, and by the way, everything that I'm doing is in a video in that course. So you don't have to write it down, you just get access to the course and watch it. And then at home you can go step by step and follow along with the video and all of that. So I'm gonna do an example project. I really like the Romy reference example because it has like the whole thing configured for me. So I'm gonna choose Java and not C++. And then the most confusing thing is all the way down at the bottom is the Romy project. So you click on Romy reference. I'm gonna put this on my desktop. Do Splash 2021 v2. Oh yeah, okay, so I need to click on desktop, and then I make the project name Splash 2021 v2. And my team number is 7272. You always have to check this enable desktop support thing, otherwise that simulator program doesn't get configured correctly and run. So I'm gonna open this in a new VS Code window, so I have two open, like the old code and new code. So what actually gets generated out of the box is a lot of stuff. It already has a drivetrain class with the Romy configured into the specific digital input and output ports, both with the encoders and the motors and the gyro and all of that. And it already has some math in here for detecting the number of inches that happen when the encoders turn, and there's an onboard I/O class as well that provides access to the buttons and LEDs. I guess I kind of skipped over that, but you can actually practice programming only with the digital I/O on the Romy. There's a ABC button, and there's a red, green, and yellow LED that you can interact with. So that's, if you use this subsystem class onboard I/O, you can actually control the lights and inputs in there. Okay, so it also has a lot of commands out of the box, and the autonomous command that I just ran earlier is in here as well. And there's a specific class for the Roamy gyro because it kind of does like a weird networking communication thing that students shouldn't have to think about or realize. So what I recommend is either using the, definitely start with this Roamy reference project so students see examples of how it actually works. And I'm gonna create a new command. I'm gonna name it, you right click on the commands folder, say create new command. You say command new, and I'm gonna say turn gyro is the name of the command class. So the Roamy reference project is using turn degrees. It uses the encoders to turn. But personally, I've found that the gyro provides a much more accurate turn, especially on like slippery surfaces. I'll notice that the turn with the encoder is kind of like way overshoots. So, the basic writing of a command is like, what subsystems am I using? I'm gonna use the drivetrain class. I think that's it. I need to define my drivetrain class, local variable instance, and I want to pass both a speed variable, like how fast the robot should turn, and I'm going to define a degrees variable. Oops. That determines how many degrees the robot should turn. And in this example, I'm going to do 90 degrees. So the constructor is where I'm going to pass the degrees, the speed, and an instance of the drivetrain. What is it? Oh, yeah. Going to do some Java wiring of like my passed in parameters to the class local variables really fast. This is all explained in the course. So the first thing I'm going to do is determine what I'm going to do when the command first runs. And the initialize method runs once. So the main thing I'm going to do is I'm going to reset the gyro's current recorded distance that it's turned. And if I don't do that, it's going to have like whatever is the current gyro heading, and what I want to do is like reset it so that it starts at 0, and then I measure the difference that happens as the command's running. I'm going to drive. So I'm going to use the arcade drive method on the drivetrain, and I'm going to not drive straight. I'm actually going to rotate at the speed that is passed in to my method. And by the way, what I'm going to call this with is an instance of the drivetrain, a speed of 0.3, and I'm going to have it turn 90 degrees. But I'll do that later. And then when I end, I'm going to stop driving. So 0, 0 means just don't turn, don't go anywhere. And my isFinished method tells the command when it should end. So while it's running, turn at the speed, rotate at the speed. When it's done, don't drive at all, just stop. But this method has to tell it what is the condition in which the command should end. So what I'm going to do is do the absolute value of the drivetrain of the get gyro angle Z, and it's in the documentation for the Romy, but Z is this direction, and I forget what X and Y is, but X is this way and Y is that way, I think, but you really only ever use Z. You can ignore X and Y because it's always running on a flat surface for the most part. And I want to make sure that the amount that the gyro turn is reading is greater than or equal to the degrees that I want it to turn. So I think that's right. I might have to go back and check, but I'm kind of just winging it here. So to actually make your command run on an input or on something, you have to go to the robot container class and you have to decide what to do with it. So at the top of this auto-generated program, there's already a controller and there's already an instance of the drivetrain, so cool. It's gonna be really easy to program something. So earlier I said it's gonna trigger when I press Z on the keyboard, which happens to be button number 1, and I'll show that in a second. So I'm gonna declare a new joystick button, not joystick, but joystick button of key Z. And I'm gonna say that that is equal to a new joystick button of my M controller, and it's button number 1. And I will show how I know it's button number 1. So say when I press that key, I'm gonna run a turn gyro command that uses the M drivetrain, a 0.3 30% speed, which is, from what I found, the lowest you can actually run on the Romy, like 0.1 and 0.2 just don't do anything. And I'm going to turn 90 degrees. Yeah, my bad. Okay, and I have to make sure I'm still connected to my Wi-Fi network. So I went into the WPILib configuration tool and I named the Romy after my team. By default, the Wi-Fi network's gonna have like the serial number of your Raspberry Pi just to make it unique, but you can rename it and change the password and all of that stuff. So I'm not gonna touch it because I'm already connected. And let's just try to run this and see what happens. Might not work. Might work. So when I open a robot project, the first thing I have to do is actually map my inputs to my project. So over here you have like these, I really don't understand why I have 4 keyboards. I feel like I should only have 1 right now. But if I press a key on the keyboard, it's gonna highlight which keyboard it is. It turns yellow if you see that. So it knows that, I know that keyboard 16, for some reason, is the actual keyboard. And when I click on Z, see how it like highlights that little yellow box? That's actually like an array of buttons, whereas Z is like button number 1. So in my code earlier, I wrote, this is like joystick 0 and button 1, and that's how that whole thing is connected. So hopefully, when I switch into teleoperated mode and I press Z, this thing is going to turn 90 degrees and then stop. So let's see if that happens. And I do see that my Romy is actually connected and communicating because I can see the Romy gyro changing a little bit. So let's see. And it did it. And is it going to stop? Okay, it overshot 90 a little bit, but I'm also not using PID at all, right? So theoretically, it should overshoot it because it's not going to be a perfect 90 degrees. There's a delay in the gyro sending back to the program what it actually is, so it will always overshoot it. If you use PID, it would notice that you overshot it and then go back a little bit and land perfectly on 90 degrees and adjust that. So that is it. Yeah, I actually just finished, so perfect timing. Any questions on anything? QA? Yeah.
I have a lot of specific questions.
Sure.
Why is 0.3 like the threshold?
I think it's just that the power range, and maybe we could adjust this as part of the Romy and make the power range be like, it's just physics. I think that it gives specifically for the Romy, anything under 0.3 gives it too low of a voltage to actually mechanically turn. But arguably we should probably adjust that in the framework of the Romy for students so that they actually see that like 0.1 moves and then the whole range is more distributed, you know? But yeah, that was one of my first gotchas when using the Romy is why isn't it going at 0.1? I thought like I had a coding error or something like that. So yeah. You had other questions?
I don't remember them, sorry.
Okay, yeah. Anything else? All right. Well, thanks. I hope this was useful and you learned a little bit about programming and the Romy, and I hope that you go and buy it right now for your team to use, and if possible, be able to like have some students take it home over the holiday break and learn programming by the time kickoff happens and all of that. So, all right. Thanks.